Anyway, it sounds like we're done with our free body diagrams and we're ready to roll. All right, at point E at the bottom. What forces do you have acting on you? Gravity's there. Gravity.
Oh, I'm hard.
Okay, and then point F up here. How does the gravity compare to point F? Same, right?
Yeah.
Okay.
I'm rolling.
Okay. Let me ask you this before we get to the other forces. We're moving at a uniform circular motion, right? We're going at a constant speed. How does the centripetal force up here compare to the centripetal force down here?
Same acceleration.
Still same, right? If you're moving at a constant speed, the centripetal force, which by the way is the net force, is the same up here as it is down here. Okay. Now, what's the direction of the centripetal force here?
Left.
It's up. Your velocity is left, but at the bottom of the circle, your acceleration and your force is upwards. So, tell me about the normal force at this location. How does it compare to the force of gravity? It's larger. It's got to be larger. If it's not larger, if it's the same, you're going to go sideways.
Which one is that on the drum? E or?
This, whatever, this is the bottom. I can't remember what letter it was. Okay?
But don't the normal force have to be equally as big on the upper one so they could go back down?
The normal force doesn't need to be equally as big, but the centripetal force does need to be. Okay? Now look, if I'm to analyze this free body diagram, what's the net force? It's up, but in terms of these two, what is it? Yeah. Fn minus Fg. Okay, now I get up here. Which way is the normal force pushing on me when I'm at the top? Down. Yeah. Okay, so the normal force is actually pushing down this way. And what's my net force at the top equal to? Yeah, Fg plus Fn. Those two are both working together. And hopefully you can see that for these two statements to be the same with the same net force, the same centripetal force, the normal force down here has to be a whole lot bigger than it is up here. Yeah, Astrid. Yeah, that's exactly right. We're going to be talking about weightlessness, but yeah, she asked me in here, why you feel weightless at the top. Remember, your weight you only sense as a support force. If there's nothing supporting you, you feel weightless. If you get going at just the right speed, there won't be any normal force at all. It won't push on your bottom. Okay, all you'll feel is gravity, and that will be the centripetal force at the very top. But when you get down here, right, if you were sitting on a scale as you're going around that ride, the scale would read really high here, really little here, and it would just keep on cycling back and forth. Okay. Watching that are different. Okay. I get a lot of, well, I don't even want to know if I want to go here right now. Maybe we'll talk about that on Thursday. Yeah, what time do we have here?
11:33.
I think we do have enough time to talk about it.
I don't think so.
I know it's a rainy day and we feel a little bit lazy on that rainy day. The problem I keep getting year after year is, well, when I go around the bend, what do I feel? When I go around the bend. When you're driving or when you're, say you're going, since we're talking about Kennywood, say we're going down the hill on the Thunderbolt. Sorry. The Thunderbolt heading towards the potato patch. Right?
The first one or the second one?
First one. Okay. What do you feel?
Then you just say what? I mean,
I feel awful.
Feel awful. All right.
I hate going downstairs.
I'm not.
Oh no. I do. I hate going.
You have a picture of this?
yeah, like the first one where you go like that, man.
Yeah. Okay.
Okay.
So we're coming down right here, right? They always tell the smaller person
Yeah.
to get in first.
Yeah.
Really?
They tell you that, and there's a sign and everything, because the person on the outside feels like they're getting smushed, right? The person on the inside feels like they're pushing outwards, right? And when you take a sharp bend in your car, you feel like you're being thrown up against the wall.
You like,
What's that?
Inertia, you feel like you're being thrown against the car.
That's exactly right. You're not actually pushing against the car is actually pushing on you. We're gonna pick up there, but I want to leave you with a little video of a ride that used to be at Kennywood that shows this.
The Gold Rush?
that little blue one?
Yeah, it's called the Rotor. This one's just like it in Germany.
Hamburger Dome?
You should be able to explain this.
Do you remember this, Michelle? Because I don't.
The worksheets you got on the way in were doing the first 10 problems.
It'd be cool if you had the camera pressed against. Oh dear.
So they spin that really fast and then they drop the floor out.
How they have the power? But how do you move his arm? Like, how can you move his arm like that? How could they all move their arms like that?
He's saying that. He says like 3 times. It's really I don't know.
If you remember this, Michelle, I bet you wrote this.
You can still move your arms.
But like, couldn't move it on that giant, on the move ride, not on the move ride, but like the ride where you have to be pressed up against the wall and they drop the floor beneath you again. But like, but you have to hold on to these poles. Yeah, like, I don't know, you can move your arm.
Hold on to it, because you're not going anywhere.
What?
You really don't need to hold on, you're not going anywhere. Your body wants to keep on going this way, right? So the wall gets in the way and pushes you in towards the center.
They're probably gonna drop back. That'd be hilarious.
Okay. So what is happening here, guys?
Why did they get rid of it? Hamburger.
I think they were tired of cleaning vomit off of the floor, to be honest. They got a little smelly in there.
Didn't look too bad.
They got that somewhere else. I just can't remember.
I don't know why you got a blue filter on though. We're gonna have a field trip to Kennywood in the future. In Kennywood, we'll go physics day or something.
We'll talk about them and we'll do a lab on Thursday. 1 through 10 on that worksheet. Just 5.